Hi guys, in the previous lecture we have seen the DC transient with sources considering initial condition at t is equal to 0 plus and final condition at t is equal to infinite. So we have seen some problem based on initial and final condition. Like in these categories we have seen that if the inductor is charged initially, then IL of 0 minus is equal to IL of 0 plus is equal to some value having constant value k. Okay, and at t is equal to 0 plus, this inductor is replaced by one current source having value k. And if the inductor is not charged initially, then IL of 0 minus is equal to 0, that is equal to IL of 0 plus. So we replace the inductor in this case by open circuited because current is 0 initially. Similarly for capacitor, if Vc of 0 minus is equal to Vc of 0 plus is equal to having some value, means the capacitor is charged initially, then that capacitor is replaced by one voltage source V at t is equal to 0 plus. Okay, we are replacing capacitor by one voltage source at t is equal to 0 plus. Similarly, if Vc of 0 minus is equal to 0, means capacitor is not charged initially, then Vc of 0 plus is also equal to 0. So in this case we replace the capacitor by short circuiting, okay, at t is equal to 0 plus. So these all things are done at t is equal to 0 plus with initial condition. Now at a steady state, means at t is equal to infinite. At t is equal to infinite, inductor can be replaced by short circuit and capacitor can be replaced by open circuit. This we have discussed in theory tutorial of DC transient. Okay, now today we will be discussing about DC transient with sources response having 0 less than t less than infinite condition. Means we have to find the capacitor voltage or inductor current for t greater than equal to 0 when the source are connected. Okay, so we will see some problem based on this. So let us see how to proceed with this type of problem. Okay, so let us take some important point, like if network contains several sources, means network having multiple sources and having several resistor and several inductor, and that network are separable, means resistor and inductor are separable, then IL of t for t greater than 0 is equal to IL of infinite plus IL of 0 minus IL of infinite e to the power minus t upon tau. We use this equation in order to find the response of current for t greater than 0 in category 3. Okay, similarly we can find the voltage across capacitor in when the network contains several resistors, several capacitor, and the R and C are separable, then the response across the capacitor VCT is given by Vc of infinite plus Vc of 0 minus Vc of infinite e to the power minus t upon tau. These two formula we will be using in category 3 in order to find the response in the network. Okay, but these two formula are used when resistor and inductor are separable or resistor and capacitor are separable in case of RL and RC circuit respectively. What will happen if the RL and RC are not separable? Then in that case we use Laplace transform approach to find the response in the circuit. Okay, see, this is not new formula. Like for source free RL circuit, we have seen in source free RL circuit the energy present in the inductor is 0, means IL of infinite is 0. Okay, so put IL of infinite in this equation, you will get IL of t is equal to IL of 0 e to the power minus t upon tau. This is nothing but discharging equation of RL circuit which we have seen in source free RL circuit. Got it? Similarly for RC circuit, in source free RC circuit, if we put Vc of infinite is equal to 0, because at a steady state all the energy present in the capacitor will get dissipated across the resistor. So Vc of infinite we will get in case of source free RC circuit will be 0. So put Vc of infinite here, you will get the same equation that we have discussed earlier while solving the problem based on RC circuit, that is equal to Vc of 0 e to the power minus t upon tau. So these two equation we have seen. So this formula and this formula is applicable for source free RL and RC circuit also. Only you have to put IL of infinite is equal to 0 and Vc of infinite is equal to 0. However, in category 3 we will not get IL of infinite is equal to 0 and Vc of infinite equal to 0 because source is connected at steady state. We will see some problem based on this. Let us see the first problem. See, in this problem the input source is 20 ut and we have to find the voltage across capacitor for t greater than 0 and current across capacitor for t greater than 0. Okay, let us see the voltage source. Voltage source is 20 ut, that means source is applied for t is equal to 0 plus. At t is equal to 0 minus, there is no source present in the circuit, means at t is equal to 0 minus this network is not charged. So we can say that Vc of 0 minus is equal to 0 volt and that is equal to Vc of 0 plus, that is equal to Vc of 0. Okay, because for t less than 0 the source is not present, means capacitor is not initially charged. Now we will draw the circuit at t is equal to infinite. What will happen at t is equal to infinite? Since at t is equal to 0 plus, source having 20 volt magnitude is connected, and at t is equal to infinite all the capacitor will charged at its final value, so it will get open circuited. Capacitor get open circuited at t is equal to infinite, that is at a steady state capacitor get open circuited. So let us draw circuit at t is equal to infinite. Okay, since this is open circuited, so no current will flow here, so no drop across this 1 ohm resistor. So voltage across capacitor at t is equal to infinite will be nothing but the voltage across this 2 ohm resistor. Okay, this is Vc of infinite, which is given by which you can easily find by voltage division rule. Since 2 and 2 are connected in series, this is open circuited, so equal voltage drop will be there according to voltage division rule, that I will get 10 volt. Okay, so now you have to find the Vc of t for t greater than 0. What is the formula for Vc of t for t greater than 0 in category 3? That is equal to Vc of infinite plus Vc of 0 minus Vc of infinite e to the power minus t upon tau. And we clearly see here that these two resistance and capacitance are separable. Okay, so time constant is nothing but RC. R equivalent you can find across this point. Short circuit the voltage source, you will get 2 parallel with 2, that is equal to 1, 1 in series with 1, 2, and C is 1 farad, that is equal to 1. So time constant is 2 second. Now put the value of Vc of infinite and Vc of 0. Vc of infinite is 10 plus Vc of 0 is 0 minus 10 e to the power minus t upon tau. Take 10 common, you will get 1 minus e to the power minus t upon tau. This is nothing but charging of RC circuit. This is charging of RC circuit, which we have seen in lecture number 12 when I teach you the transient basic, that is the first lecture, in which I have used the charging of RC circuit. Now we found Vc of t and we have to find the next Ic of t. What is the Ic of t? We know Ic of t is equal to C dV by dt. Okay, differentiate this voltage equation with respect to time, you will get C d by dt of 10 into 1 minus e to the power minus t upon tau. Differentiate, you will get C 10 upon tau e to the power minus t upon tau. So finally 5 e to the power minus 0.5 t ampere. So in this way we can find the voltage across the capacitor for t greater than 0 and current across the capacitor for t greater than 0. Got it? Only you have to remember the one formula, that is equal to Vc of infinite plus Vc of 0 minus Vc of infinite into e to the power minus t upon tau. We will make the circuit for t is equal to 0 and t is equal to infinite, and we will find the initial condition and final condition and put those condition in the formula. We will get Vc of t. Okay, let us see the next problem. See, in this problem, two voltage sources are connected. One is having u of minus t and another one is u of t. What is u of minus t? U of minus t is having magnitude 1 volt for t less than 0. Okay, for t less than 0, this is having 1 volt. And what is u of t? U of t is having magnitude 1 volt for t greater than 0. Got it? Means for t is less than 0, source is active, and for t greater than 0 also source is active. So we have to find Vct for t greater than 0. So let us make the circuit for t is equal to 0 minus. See, for t is equal to 0 minus, this ut will not be active. Why? Because it will be activated only for t greater than 0. So it will be short circuited and I will get only u of minus t having 1 volt magnitude. This is 1 volt and the circuit will look like this. And for t is equal to 0 minus, this source is connected. That means this network is at a steady state, and we know that at a steady state capacitor can be replaced by open circuit. This we have seen in previous lecture. Now find the Vc of 0 minus. Vc of 0 minus is nothing but voltage drop across this 2 ohm, because this 1 ohm is open circuited, so no drop across this 1 ohm. So voltage drop across this 2 ohm will be the Vc of 0 minus, that is given by voltage division rule, that is equal to 1 multiplied by 2 by 4, that is equal to 0.5 volt. And we know that capacitor won't allow sudden change in voltage, that means this is equal to Vc of 0 plus, that means this is equal to Vc of 0. Now we find the first condition, initial condition, Vc of 0. Now we have to find Vc of infinite in order to find the Vc of t. Now we will make the circuit at t is equal to infinite. At t is equal to infinite means at for t greater than 0, this u of minus t will get having value 0 volt. See, u of minus t for t greater than 0 is 0 volt, so it will be short circuited and only u of t will get activated. And at t is equal to infinite, the capacitor is fully charged, so we can replace this capacitor by open circuited because it is at a steady state. So at t is equal to infinite, same circuit you will get like t is equal to 0 minus, this capacitor will be open circuited and we will find Vc of infinite. Vc of infinite, again I will get the voltage across this 2 ohm resistor, that is equal to 0.5. So Vc of infinite is also equal to 0.5 volt. Now what I will do, I will put these two value in voltage equation. What is voltage equation? Vc of t is equal to Vc of infinite plus Vc of 0 minus Vc of infinite e to the power minus t upon tau. Okay, put the value, you will get 0.5 plus 0.5 minus 0.5 e to the power minus t upon tau. Now to find the time constant, what we have to do, we have to separate the resistor and inductor, so and short circuit this voltage source. So at this point the resistor and capacitor are separable, so time constant is given by R equivalent into C equivalent. To find R equivalent across this point, 2 parallel with 2, 1 in series is 1, 2, and C equivalent is 1 farad, that is equal to 2 second. Okay, in this way you can find Vct for t greater than 0. Let's solve another problem. This question is saying assume Vc of 0 minus is equal to 0 plus and find Vc of t. In the question itself it is given Vc of 0 minus is equal to 0 volt, that is equal to Vc of 0 plus, means Vc of 0 is equal to 0 volt. Okay, now we have to find the Vc of t for t greater than 0. What is the equation of Vc of t for t greater than 0? Vc of infinite plus Vc of 0 minus Vc of infinite e to the power minus t upon tau. Okay, we can easily find time constant here because resistor and inductor are separable. You will get time constant is equal to 2 second only. Okay, now we have to find the Vc of infinite. See, these 4 volt sources are connected for t greater than 0. At is equal to infinite, this network is at a steady state. So at a steady state, what I will do, I will replace capacitor by open circuited. So when you will replace the capacitor by open circuited, then you will get the circuit like this. This is my Vc of infinite. Vc of infinite is nothing but voltage across this 2 ohm resistor. Okay, so voltage across this 2 ohm will be given by voltage division rule, that you will get 4 multiplied by 2 by 4, that is equal to 2 volt. Now put it in the equation. 2 plus Vc of 0 is 0 minus 2 e to the power minus t by 2. So take 2 common, you will get 1 minus e to the power minus t by 2. This is the answer. Okay, now let's solve some IS 2013 problem. Okay, we have to find IL of t for t greater than 0, considering we have to assume that IL of 0 is equal to 2 ampere. It is given in the question only, so no need to find the initial condition. Only we have to find the final condition. IL of t is given by IL of infinite plus IL of 0 minus IL of infinite e to the power minus t upon tau. Okay, so if I will find IL of infinite, then I can easily find IL of t because IL of 0 is already given. So make this circuit for t is equal to infinite. At t is equal to infinite, this network is at steady state, so inductor can be replaced by short circuit. So make this circuit, this is ut, means 1 volt. Inductor is shorted at t is equal to infinite because at a steady state inductor behaves like an short circuit. So IL of infinite is given by total voltage upon 2. This resistor is of no use because of this short circuiting. So IL of infinite is given by 1 divided by 2, 1 by 2. Now put it in the equation. IL of infinite is 0.5 plus IL of 02 minus 0.5 e to the power minus t upon tau. You will get 0.5 plus 1.5 e to the power minus t upon tau ampere. That is the answer. Now suppose in this question we have to find VL of t for t greater than 0. How will I find? We know that voltage across inductor is L di by dt. So if I will differentiate this inductor current with respect to time, then I will get VL of t, that is equal to L. L is given by 1 Henry, so take this 1 di by dt. Differentiate this inductor current with respect to time, I will get 1.5 upon tau in negative e to the power minus t upon tau. So this is the voltage across inductor for t greater than 0. Now solve this problem. This has been asked in GATE 2004. What the question is saying, capacitor initially has a charge of 10 coulomb. Okay, this capacitor has initially a charge of 10 coulomb and the current in the circuit 1 second after the switch is closed. We have to find IL of t at t is equal to 1 second. So if I will find, this is not IL, this is IC because capacitor is connected. IC of t at t is equal to 1 second we have to find. We know that IC of t is equal to C dV upon dt. Okay, so if I will find Vc of t for t greater than equal to 0, then I can easily find IC of t. So first find Vc of t for t greater than equal to 0. We know that Vc of t is equal to Vc of infinite plus Vc of 0 minus Vc of infinite e to the power minus t upon tau, where tau is the time constant and time constant is given by R multiplied by C. Here R is 2 ohm and C is 0.5 ohm, so tau is equal to 1. Okay, now find Vc of 0. We don't know how to find the Vc of 0, but here one initial condition is given, that capacitor having a charge of 10 coulomb, means at t is equal to 0 minus this capacitor is having a charge of 10 coulomb having polarity like this. So we know that Q is equal to CV. So Vc is equal to Q by C. 10 coulomb is the charge, 10 by 0.5, that is equal to 20 volt. So we can say that at t is equal to 0 minus, the voltage across this capacitor is equal to 20 volt, that is equal to Vc of 0 plus, and that is equal to Vc of 0. So we found Vc of 0. Now I will find the voltage across capacitor for t is equal to infinite. So clearly we can say that when switch this is closed, then capacitor will charge initially, and at a steady state it will charge fully, that is equal to source voltage, and it will get open circuited. So the at t is equal to infinite, the circuit will be like this. This is 100 volt, this is 2 ohm, and this capacitor is open circuited having Vc of infinite value. This is nothing but 100 volt. Okay, now we know Vc of 0 is equal to 20 volt and Vc of infinite is equal to 100 volt. Now we can find Vc of t. Vc of t is equal to Vc of infinite, that is equal to 100, plus Vc of 0 20 minus Vc of infinite 100 e to the power minus t upon tau is 1 second, so e to the power minus t. That means finally I will get 100 minus 80 e to the power minus t. This is my Vc of t, and we have to find the Ic of t for at t is equal to 1 second. Means find Ic of t first. Ic of t is c dv by dt. What is c? C is the 0.5, and we differentiate this Vct with respect to time. I will get 80 e to the power minus t, that is equal to finally Ic of t is we will get 40 e to the power minus t. Okay, now we have to find Ic at t is equal to 1. So put t is equal to 1 in this equation, 40 e to the power minus 1, that I will get 14.71 ampere. So option A is correct. Let us see this problem. This has been asked in GATE 2014. Switch is at position 1 for long time, means this switch is connected to position 1 for long time, and at t is equal to 0 plus, this switch is moved to position 2. Okay, assuming V of 02 greater than V of 01, the voltage Vct at t greater than 0 will be what? Let us take the option also so that you can answer. So this was the option given for this question. So first I will find at t is equal to 0 minus, this switch is connected to this 1 point, means at t is equal to 0 minus, the network is at a steady state, so the capacitor can be replaced by open circuited. Okay, at a steady state capacitor is replaced by open circuited, and we get Vc of 0 minus, that is equal to V of 01. Okay, and that is nothing but Vc of 0 plus and Vc of 0. So finally I will get Vc of 0 is equal to V of 01. Now I will find at t is equal to infinite. Now see, at t is equal to 0 plus, this switch is moved to position 2, means at t is equal to infinite, this network is at a steady state. So voltage across capacitor, this capacitor will get open circuited, and voltage across capacitor is nothing but the source voltage, that is equal to V of 02. So Vc of infinite is equal to V of 02. See, here I will take only magnitude. Why? Because the polarity of voltage across capacitor is not given in the question, so I will take only magnitude. Now we know Vc of infinite, we know Vc of 0, then we can easily put the Vc of 0 and Vc of infinite in the voltage equation, that is equal to Vc of t is equal to Vc of infinite, that is V of 02 plus Vc of 0 V of 01 minus Vc of infinite V of 02 e to the power minus t upon tau. Tau is nothing but time constant. Time constant is R R, that is 2R connected in series multiplied by C. So time constant will be 2RC. So this is the equation of Vc of t. Now when you will see in the option, then you will not get any option matching with this equation. So we have to arrange this equation such that I will get any one option. So what I will do, I will take negative from here. I will get V of 02 minus V of 02 minus V of 01 e to the power minus t upon 2RC. Correct? Now what I will do, I will add V of 02 here. V of 02 I will subtract. V of 02 minus V of 01 I will subtract. I will get V of 02 minus V of 01 e to the power minus t upon RC, and here I am subtracting, means I have to add V of 01 here. Now take V of 02 minus V of 01 common. I will get V of 02 minus V of 01 into 1 minus e to the power minus t upon 2RC. This is 2RC. Okay, plus of V of 01. This is the option D. So option D is correct. Got it? That's all about DC transient. In the next lecture, we will see AC transient. So if you guys are having any doubt in DC transient, then put it in the comment below or ask in the Facebook group. And for new updates, please subscribe to this channel. Thanks for watching this video.